How does GLP-1 work? So it is part of the enteroendocrine system, and this system has a paracrine effect, so that it's just a localized effect. There's an endocrine effect where the hormone has to be sent through the blood to distant cells, and then there's a synaptic effect that travels via the nervous system. So it was originally thought that the vagus nerve was involved with transmitting GLP-1 signals, or GLP-1 itself, to the brain, because it's obvious, it's an obvious connection. And there are GL1 receptors on that vagal pathway, and so it kind of made sense. But turns out that's not the way it works. They did some research where they cut the vagus nerve, and they found that there's no impact on the brain function in regards to GLP-1. So that wasn't the way that the brain and the gut is connected. So now we're thinking that the GLP-1 influence on the vagal system is just short-term and local. So the way that they're understanding it now is that GLP-1 works on the intestinal fuel neurons. These are in the muscles of the intestine, and they connect to the sympathetic ganglia. And then that is part of the system that takes the information back up to the brainstem and the brain. And that's the way appetite suppression is driven. So it's via the intestinal fuel neurons. So as I mentioned, these intestinal fuel neurons are part of the lining, or the muscle part of the intestine. And they're connected to the sympathetic neurons by the spinal cord. And so there are reflexes that are related to this system that inhibit gut motility. And this whole system is related to the microbiome. Its ability to function well is related to the microbiome. It has a long circuit and a short circuit. The short circuit is just for the gut. Neurons that are activated and communicate just inside the gut. The long circuit goes all the way up that spinal cord. Sympathetic, sympathetic, sympathetic. So remember, we need a balance in the body between parasympathetic and sympathetic in the autonomic nervous system. We need both of those things. But if we don't want too much of either one of them, we want the right amount. And what we're hearing here is that GLP-1 activates the sympathetic nervous system. We're recalling that the way the body wants GLP-1 to be activated is briefly. The body's not designed to have a thrashing of the sympathetic nervous system by GLP-1. The ileal brake system is the inhibitory feedback mechanism that controls transit of a meal through the GI tract. This is what helps us to absorb nutrients optimally. If it's sped up, then we'll get diarrhea, malnutrition, and malabsorption. GLP-1 is considered to be an ileal brake hormone. And so it is what helps us to be able to absorb nutrition by regulating the speed of transit in the gut. And this works primarily via the sympathetic nervous system. So this is a mouse, you can see, and it just kind of goes through how in the mouse the enteroendocrine cells are in the ileum, the last section of the small intestine. And that's where GLP-1 is activated by nutrients that those cells, the enteroendocrine cells, are then connected or relay to information to the abdominal sympathetic ganglia. That then influences nitric oxide production and is related to a change in gastric volume. The dorsal root ganglia and the spinal cord is activated, and that sends information up to the hindbrain, the hypothalamus. And then you get that sense of like, oh, I don't want any more food, that's enough. And that's the way that GLP-1 is connected all the way up into the brain. How does the sympathetic reflex circuit work? The sympathetic reflex circuit is the major firing pattern for the enteric nervous system. So the gut is what uses the sympathetic reflex circuit. It is in charge of gut motility, and it comes from the interfugal neuron sympathetic circuits. This again is primarily located in the muscle wall of the gut, and that is also where nitric oxide synthase is used to promote gastric relaxation and appetite suppression. The neural circuitry also includes the pancreas and the liver, although it's not dependent on GLP-1. Oh, there we go. Okay, so in mice, the GLP-1 acts on this ilioenteric neurons. And that, as I said before, mediates the gastric and anorectic effects. So it makes you feel like you don't want to eat. It has to do with gastric distension, and this information is sent up from the gut into the brain, into the hypothalamus. And that's what ultimately makes you feel like not only full, but just like, I don't want to, that's gross. Food is gross. So my understanding now of the way that GLP-1 works in our body is that basically it flips the switch to this intestinal fugal neuron circuitry. So that it's not really exactly, the important thing is not really exactly how it works on the pancreas or the liver or the heart, or I mean all of those things are not its major way of contributing to weight loss and low appetite. It's actually this intestinal fugal neuron system, and that's the sympathetic part of the nervous system. So once it flips that switch, then this circuit kind of is activated and takes off and does its own way, its own thing. So the ideas of the endogenous GLP-1 are that where GLP-1 is produced, DPP-4 is also produced. They are always produced close to each other because the body demands a short half-life for GLP-1, and DPP-4 is what makes that short half-life. Some types of inflammation increase GLP-1. GLP-1 promotes systems that can be hyperproliferative, like macrophages 2. GLP-1 acts as a switch for the neuroendocrine system that links the brain and the belly.